Today we will see the mole concept and Avogadro number. So what is a mole concept? It's a unit of measurement. So what do we measure using mole? We can measure any elemental entity such as atoms, electrons, molecules, or even ions. So anything which is small or minute. You know that 1 dozen is equal to 12 units, right? So when you ask for 1 dozen of donuts, for example, you will get 12 donuts. Similarly, if you ask for 1 mole of something, you will get 6.022 into 10 raised to 23 units. Here in this case we can say as particles, and these particles can be anything like atoms, electrons, molecules, or even ion. So when I say that I have 1 mole of atoms, it means I have 6.022 into 10 raised to 23 atoms. I hope that's clear. And this number is called as Avogadro's number, or AN. We can represent it by AN for now. Avogadro number is named after the scientist, the physicist Amedeo Avogadro. So how did Avogadro number came to existence? Was it just a random number? No, it was precisely calculated. For that, the scientist took a standard element, carbon-12. Why did they choose carbon-12? Because it's stable and pure. C12 is the most abundant isotope of carbon, and it is present in 98%. And it has a whole number, which is 12 atomic mass unit, which is a whole number, and it makes the calculations very easier. So who want to complicate life, right? Even scientists want to make their life easier. So they have chosen carbon-12, which has a mass of 12 atomic mass unit for 1 C12 atom. So they have taken 12 grams of C12 atoms and calculated the number of atoms inside that. So they found out that 12 gram of C12 atom contains 6.022 into 10 raised to 23 atoms. How did they calculate this? They have used a lot of experiments, precise experiments and calculations like charge to mass ratio, X-ray crystallography, and a lot of experiments to come into this conclusion. And why did they not choose oxygen? You might think, right? Or any other element. For example, oxygen exists as O16, O17 and O18. Those are the different isotopes of oxygen, and they exist more abundantly than C12. So they have different atomic masses, which will cause inconsistency in calculation. So to make it easier, they have standardized carbon-12's atomic mass unit as 12 and decided that we'll go along with this. So how will you define 1 mole? 1 mole can be defined as the number of atoms present in 12 grams of carbon-12, a pure carbon-12. 12 grams of C12. So we know that Avogadro number is big, but how big it is? Let's consider an example. So if you take Avogadro number equivalent of donuts and you spread on the earth's surface, you can cover the whole surface of earth, plus you can extend it to space. And if you consider it in terms of time, if you start counting 1 second if you start counting 1 number per second, it will take you 19 trillion years, which is more than 1 million times the age of the universe. That's how big is Avogadro's number. I hope you learned something new And whenever you see Avogadro